All right, so this video we're going to talk about doing the roller coaster simulation lab. So you should have just learned about energy, energy transfers, what kinetic, what potential energy is. So we're going to take it to the next level here and actually do a lab with that. Okay, so let me show you the simulation part. So I'm going to share my screen here. And we'll go to the lab document. So you have access to this document. It's on Canvas. So I just want to show you this. The first part of this, you actually don't need to do anything on the simulation with. The concept review, all right, so this section here, you can answer without even doing anything with the simulation. It's just like background information, background questions for you to answer. Okay, so answer those complete sentences. So you could type in the document and save it. You could print it out and uh, write on it and then upload a picture of it all. It doesn't matter whatever way you want to submit it here. All right. So answer these questions, complete sentences before you get started with the simulation. So next, I'll show you how to. So it shows you how to get to it right here, but I'll show you how to get to the simulation. So open up a new window. You just type in PHET simulations, and then it'll take you to this website here. And then you should see the physics button, and you want to look for Energy Skate Park. Okay, you can click that and then click play. All right, to start, you're going to click on intro. Okay, and it's going to set you up like this. This is perfect. This is exactly what you need to have happen. You need to have a track with just a little U. So if you have to hit intro, and you can change it here. You can change it, but we want this one right here. We want the U. Okay. So what's going to happen here? So I go back to the thing, the exploration questions. So all these questions here have to do with this situation right here. So all you're going to do is drag the little girl, skater person thing onto here, and you're going to let them just go. All right. And then answer the questions. It's going to tell you some things. It might say, okay, click on the energy bar graph. The bar graph's right here. Click on the pie chart. The pie chart's right here. You're good to go. You can change mass. All right. You can change friction. Okay. So these basically all your options. You can use this as a measuring device, right? So if I need to know how tall the first hill is, I can measure stuff like that. Okay. Um, so yes, the intro question or the is it intro? No, exploration questions are going to be answered just about that situation. So once you're done with that, okay, once you're done with that section, you'll come here and you'll go to playground. Okay, so you go to playground. Now this is a little bit different than when I wrote the lab. So you don't have unlimited track. So you used to have unlimited track here, but you don't anymore. So what I want you to do is just build some sort of roller coaster. You got to conserve the track because what am I gonna say? It's you don't get a lot of it. I don't know, whatever you want to do. You can build one that just has a little hump. You could make a loop. But I want the person to like roll out on the ground. So I'm gonna make it real basic. Make like a loop or something or a bigger hill. Try to do something here. I'm just for the sake of saving time, just to show you. But you have limited amount of track. But what you can do is you can space this out. So I can make in between, each thing further. So to give you because you only get that many pieces of track. So I think it's 1, 2, 3, 4, 5. You get 5 pieces of track, and each track has 3 little hinges. So once you're done with your oh you cut it. I didn't know that. You can cut it into 2 pieces. I don't know really what that would do. Um, but yeah, or you could delete it. I just wanted to delete it. All right. So Once you get to this point, it's going to say build your own roller coaster. This is you building your own roller coaster. And it's going to ask you some different things. You got to make sure it works first. And I believe it wants you to start without any friction. So make sure friction's none. Make sure stick to the track is there. All right. And you see if your skateboarder goes through the thing. All right. Fantastic. Obviously, she was going to go through it. You know, if you start putting loops in and stuff like that, that's when you got to make sure they go through it. Okay. So again, mine's really basic. Make yours a little bit more complicated than this. This is just for the sake of the video. All right. Now, when it asks for energy at the highest point, well, you know the mass of the skater. The mass is right here. So when we talk about, you know, what variables do we know? We know mass, okay? And using the little thing here, I can measure the height at any point. So this number right here, gives me the height, right? And I know so for, all right, I can find my potential energy at any point because I have a something to measure the height with, right? So at any point I can find my potential energy. Now, if I have zero friction, that means it's a closed, isolated system, okay? So initially, if I bring this girl back, her initial velocity is zero, right? I just set her here, watch, I set her here, she has zero velocity. So all she has is potential energy, right? So that way I know the energy total there, and I know the energy total at any single point here, okay? So as you go through this, it's going to ask you to add some friction. So if I add friction, maybe she won't make it. She does make it. Let me try to make it so she doesn't make it. So maybe if you make something like this and then, okay, that didn't work. Let's see if this works. All right. Skater, you're making me look bad. All right, here we go. Oh, whoa, 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 whoa. Oh no, my roller coaster doesn't work with friction. So I would have to change something. I'd be like, okay, to change this, I would have to, you know, bang, lower this hill. And then I would bring her back. All right, come on, chick. There we go. Oh, now it works. So this is going into the next part. So you're building your own roller coaster. All right. You don't have to show me your successful design. Just sketch it there. All right. Label it where you're slowing down, speeding up. Okay. Um, then you're going to do the track friction. So you're going to add some friction and see if they make it. If you had to make any adjustments, then that's fine. You just have to tell what adjustments you made. So that's going to walk you through this part right here. Okay. Now you're going to actually have to do some measuring. So, I mean, it's pretty straightforward. Measure the height of the first hill. Calculate the potential energy at the first hill. That's straightforward. The total energy, I talked about how to do that. Calculate the velocity of the bottom of the first hill. So if I look at the velocity, well, I know the energy total. So whatever the energy total was here, I know it's going to be the same down there. It's going to be the same energy total. But what you have to notice is the bottom of this first hill is not at the ground. It has some height, right? It has, see, it is, you know, 0.5 meters off the ground. So it has some potential energy here. So I have to remember that E total is equal to UG plus kinetic energy. So if I can calculate using this to find my potential, I already know my energy total from this point up here. I can find what's left of my kinetic energy. And then once I have kinetic energy, I can find my velocity. All right. Let's see here. What's next? All right. So that gives me the velocity at the bottom of the first hill. And then they want you to do the same thing. Calculate the potential energy and kinetic energy, the velocity of the coaster at any other point. So you could pick this point. Like say I wanted to figure out, you know, at this point where what the kinetic and potential. So I remember, I know energy total is the same. If this is the point I pick, it's the same as the point I already used down there for the lowest point and the point there. So I know the energy total, and it equals UG plus kinetic energy. Well, you can find potential energy real easy, right? You find it real easy. You scroll this over. At this point here, I know it's 2.8, so I can use this information to find potential. So I know potential, and then I can use that to find kinetic energy. All right, so that's the coaster specifics. You're going to be measuring some things about your particular roller coaster. So it's not the same as mine. It's not the same as anybody else's. It's yours. All right, and then once you get that, there's post-lab questions. All you have to do is finish those, write in complete sentences, and then submit. All right, good luck. You know, I'd much rather be doing this in person because we'd be physically making the roller coasters, but it is what it is. Email me if you have any questions. Thank you.